So we want to see if the sex of a victim is related to the sex of the offender. So going back to that serial killer database, we found out that statistically speaking, most women, their choice of or mode of killing is poison, and it's a fact statistic. So we want to see if there is a connection between the offender's sex and the victim's sex. Now, just by looking at that table, it's, looks like it. If you go from here to there, it seems so. But if we want to come up with a measure of association, we want to know which the response variable is, because there are two of them here. So which is explanatory, which is response. We're not able to distinguish in this case. So we're doing a chi-square test of independence and not a test for, what is that other one? Starts with H. Ends with T. 80. Do we read? Test for homogeneity, right? If we can distinguish between the explanatory and response variables, it's typically a test for homogeneity, but regardless of what you call them, the process is the same. So I am going to use Star Crunch instead of SPSS because it won't do a crosstab directly. So we're guessing send that up, let's have leave. So contingency table, row labels, male, female, male. Column labels, female, male. Row variable, sex of offender. Column variable, sex of victim. Compute. We see nothing. We have to enter the counts. The counts 124, 421, 1609, 3725. Good. It did compute for us. In the previous case, we typically saw something shaded over here under the curve, and it was in red. I see nothing. Why?
Can you repeat that?
In the past, with a different problem, there was, area under the curve shaded in red. I'm not seeing anything. Why? What does the area under the curve correspond to?
The rejection.
Okay, rejection area, but what does the area above the test statistic correspond to? Critical value. Area above the test statistic. You can look at your notes. Area above the test statistic. Now, from previous cases, we would see an area under there because the p-value was reasonably large. Here, it is 0.0003, and we can't sketch that over there. Hypothetically speaking, let's say if I change that 421, oh, it's still right. I'll change that to 12, 16. You can see it's popping up. Yes. So in that case, we have a p-value that you can visualize. Last time it was 0.0003. You can't visualize that area, which is why we weren't able to see it. So going back to our problem, the p-value was 0.0003. The chi-squared test statistic is 13.07. You can use the critical value method to come up with a conclusion also. I'm going to just stick with what Stackbridge did. Now we're treating the response variable to be the sex of victim. $17.33 and 41.46. The total here is 58.79, 545, and 53.34. Good. We have to, compare conditional probabilities, not just, these probabilities wouldn't make sense in this problem. So these are conditional probabilities going back to the first week of classes, maybe the second. So P1 is the probability of a female victim, given that the offender is male. P2, probability of a male victim, given that the offender is male. So how do we find those probabilities?
Number 5879.
1609 over 5879. Is it right? You say no, why?
It's we do the 545 over the total.
No.
Before the one.
421. So we are conditioning on a male offender. In other words, which group are we looking at? Males or male offenders or female offenders? Male offenders. How many male offenders do we have? Louder. 5,334. Relative to those male offenders, we want to know how many of them had female victims, correct? That's what conditioning means. Got to read, people. So P1, right over here, is simply 1609 divided by 5334. What is that number? The P1 is 0.3016. How do we find P2?
Would be the same, except we'd be using for the top, it'd be 3,725.
Would it? Yes. Good. So it's 3,725 divided by 5334. What is it? 0.6984. Yes. No, wait.
Yeah, yes.
Okay, now I want you to divide the two. The book wanted to pick one measure of position, we're about to run out of time, so I don't want to bring up odds ratio. P1 over P2 is relative risk, or R. And what is P1 over P2 in our case? 0.3016 divided by 0.76984. And what do we get?
0.4318.
0.4398. 18, okay. So P1 is equal to 0.4318 P2. Correct? Yes?
Yeah.
Is it significant? Well, we already found an association. All we have to determine now is if it's significant, is strength of that association. That relative risk is close to 0. Agreed? It's 0.4318. So significant. How do we interpret this? The probability that the victim would be female is 4.318 times the probability the victim is male given a male offender. Does that make sense? So by all means, the probability that the victim is going to be a female is less likely than the probability that the victim is going to be male given a male offender. Why is it so? Let's just hypothetically pick P2 to be 60%. Yes, hypothetically. What would P1 be? 40. What would P1 be according to our relationship? You guys are just talking to yourselves. 0.3. How do we find P1 if P2 is 0.6?
Just 1 minus.
1 minus. You're not leaving this classroom until I get an answer.
P1 equals 0.4318 times 0.6.
So we know that relationship of this problem. Taking, for instance, P2 to be 0.6. If you multiply the two, what do you get? 0.4318 times 0.6, 0.24 something. 25.
0.259.
259. So let's say approximately 0.26. Yes? So if the probability for male victim given a male offender is 60%, female would be 26%. Yes? So clearly, if you have a male offender, the chances that the victim would be female is less likely than being a male. Does that make sense? Condition on being a male offender.